Hey, my name is Josh Garrick. Today I'm talking about more topics in Chem 1310. Specifically, we're going off of what we were talking about last time in Lewis structures and talking about shapes of molecules today. So, I got a couple slides again that have some background information and a couple examples on what we're talking about when we're talking about determining the shapes of different molecules, especially depending on their Lewis structures. Okay, so molecular shape is the way bonded atoms arrange themselves in 3 dimensions. Molecular shape affects molecular properties, including reactivity. Valence shell electron pair repulsion, or VSEPR theory, is when molecules assume a shape that allows them to minimize the repulsions between electron pair and the valence shell of the central atom. Both lone pair electrons and bonding pair electrons determine shape. But when we name the shape, we consider only the atom position, not the lone pairs. So this is really what we're using to determine molecular shape is VSEPR theory. It is probably the biggest part of determining the shape of molecules and depends a lot on Lewis structures. So if you don't quite understand Lewis structures, you might want to go back and review that before moving on to this. So in talking about the shapes of molecules, in the book, if you're looking at the book, you might want to look at tables 7.2 and 7.3. Tried to get them on here, but they're really small, so you might not be able to see them. But pretty much what this is just showing is that bond angles and shapes are predicted by electron pair repulsion between valence electron pairs. So if I try to zoom in, you can see we have the number of electron pairs, the geometric name, we have bond angles, and a diagram of it. So this is just some of them. Looking over here, we have linear, trigonal planar, tetrahedral. We have some bigger ones coming up, but this was just an intro to that. So in the book, it's 7.2 and 7.3. So here they are bigger. We have examples with no lone pairs on the central atoms. So these are the basic shapes, some of the basic shapes that you'll see a lot. Linear, tetrahedral, trigonal planar, trigonal bipyramidal, and octahedral, all with different angles and different amounts of no lone pairs, but it's whether you have 2 coming off the central atom, you have 4, 3, 4, 5, or 6 different atoms coming off of the central atom. So, and with this, all of our double, triple bonds, if you have them, are treated as single bonds when looking at this. So this is just showing 2 more. We have PO4, 3 minus, and PCl5. So you can see the Lewis structures again. And looking at those different tables, you go by the Lewis structure, and depending on the number of electron pairs and the number of lone pairs, you're able to determine which shape it will come out to. So this is showing what we were using for those because molecular shapes for various combinations of bonding and non-bonding electron pairs. So this is it again with the bonding and non-bonding pairs, the name that's associated with it, and the drawing of the shape. Okay. So these tables are all in the book if you want to see them closer up. But I'm just showing you real quick what they look like in this little talk we're having about the shape of molecules. So as you increase, it changes. As you increase the numbers or decrease the numbers in both. The number of electron pairs and the number of lone pairs, the name changes, the shape changes, everything about the whole molecule will change. Okay, so shapes of molecules. Molecular geometry for a larger molecule is possible. For example, vinyl alcohol C2H4O is assigned for geometry is assigned for each central atom. So for each carbon, hybridization on each central atom assists in the determination of overall geometry. So here's what we're looking at again. So it's going to be determined by each carbon, really. So here's again looking at that for larger molecules. For vinyl alcohol, each carbon has 3 bonded atoms and no lone pairs. Each carbon has trigonal planar geometry. Hybridization of each carbon is sp2. Formation of pi bonds between carbon atom forces molecules to be planar. So that's just looking at bigger molecules, because the shape can be determined for any size molecules, and that was just a real basic background information and what you want to look for when you're trying to determine shape of molecules and all that. I hope that helps a little bit. Thanks.